Okay, so we're going on to the inverse normal distribution now. So the inverse normal, the idea is that before we had like a lower bound, an upper bound, we had a mu and a standard deviation, and we found a probability. Yeah? So the inverse lets us go the other way. There are some restrictions, and you need to know how your calculator works, but the inverse can be really, really useful. If you do have the graphical calculator, it's even better. The graphical calculator is phenomenal at this, and I will cover that in the calculator use video. So we've got a situation of normally distributed. 20 and 3 are our key values. We want to find the value so that being less than this value represents 0.75, so 3/4 of the data. So first thing to say before we jump in too much is the inverse normal, at least on the standard calculator, only works from left to right. Okay? If you have the graphical calculator, this restriction is not the case, but all of the parts in this video I'm going to cover on the assumption you don't have the graphical calculator. So it means that if we're doing this question here, for example, this works well with the calculator because it's saying, you know, being less than some value. So this is perfect, but it's not always going to be the case. So here we would say, well, 50% is half of the data, so 75% will be over here somewhere. Yeah, we know that it's 20. This value is unknown. It could be 21, 22, 23, 24, something like that. And very simply, what we do is we go on the inverse normal mode on our calculator. So we go modes, distribution, inverse normal. 0.75 is our area, and remember that goes up to. That is the most important bit. We need to also tell it roughly the shape of our distribution, so where it's centered and how stretched or how compressed it is. And it gives us 22. And that value there sounds quite believable because it's got to be more than 20, hasn't it, to cover more than half of the data. So this is an inverse normal situation. Let's do some more. So B, let's do B. So being greater than some value is 0.4. So we draw it first of all. Being greater than some value is 0.4. Why did I draw my value here? Well, I know that's 0.5, so 0.4 would be something like that. The problem is, if you put 0.4 into the calculator, it's not going to work because the calculator, remember, goes left to right. So what we want to do here is we want to use 0.6, please. Okay, so again, we're going to use that mode on our calculator, but with 0.6 instead. So our answer, if here is 20, our answer here comes out to 20.76, which again makes sense. Okay, so it's left to right. Okay, in terms of the numbers were the same. I was using a mu of 20 and a standard deviation of 3. Finally, let's try something trickier. So being between 16 and some value needs to be 0.3. Okay, so being between 16 and some value, let's sketch this first. So 20's here, 16's here somewhere, and some value. Now, I don't know where A is, all right? I don't know if A is here or here or here. I know it's around there somewhere. I'm going to guess that it's about there. It's sort of an educated guess. It said 0.3, so we want this area to be 0.3. Remember, our calculator can only go from the far left all the way over to the right to reach our value. It cannot do this, all right? It's not capable of doing that. So when we have situations like this, the best thing to do normally is use one of the numbers that's there already and see what probability is attached to that. So if you do inverse normal of 16, you should end up getting 0.09121. Okay, so 0.09121. Well, this is really useful because now what I can do for my calculator is I can add these together because I know that covering this distance is equivalent to doing 0.39121. So I'm going to do inverse normal of this, and my calculator says to me 19.17. Now, what do you notice? I placed A on the wrong side because I didn't know where it's going to be. Actually, the A is over there. But this diagram is just to help me think about what's going on, okay? So if I have an answer, if I have a probability of less than 0.5, well, now I can see that. Now that's clear to me, but it wasn't clear before. It means I'll be to the left. All right, so we're doing a bit of problem solving here, really, based on working around how our calculator works. Remember, the graphical calculator, you can choose less than, greater than, you can do in between. So people on the graphical calculator can bypass largely this whole process of what we're doing. Okay, we're going to do some further examples. So here we go. We're back on IQ again of 115. It says, what IQ gives you the top 30%? Well, the top 30% means that I've got 0.7 below. So I need to do the inverse normal of 0.7 using my mu as 100, my standard deviation of 15. I'm expecting a number here bigger than 100, aren't I? So if I do that, I get A equals 107.87. Okay. Interquartile range. Well, interquartile range, remember, is about Q3 minus Q1. So Q3, your upper quartile will be at the 0.75 probability. And your Q1 will be at 0.25. So I need to do inverse normal of 0.75. I need to do inverse normal of 0.25. And then I need to subtract them, don't I? So numbers for that one again. So check, you can do this on your calculator for yourself. But I get 80... No, I don't. That's the wrong way around. I get 89.88 for this one. And for this one, I get 110.12. Okay, when I subtract, I get 20.24. Okay. And to sense check these, I could, of course, add a bit more information. I know that's 100. I know 115 is about here somewhere. So these answers sound pretty good to me. Pause the video now and have a quick go at these. There are some similarities, and we will just quickly have a go at these. Diagrams are absolutely something that you would want to draw for these ones here. So we've got 30 and 5, 30 and 5, 12 and 3. And let's have a go. So for number 1, it says less than it is 0.75. Okay, so, you can just use the calculator straight away for that one. 33.372 ... So we tend to write lots and lots of decimal places, and then underneath we round it afterwards. That's the way to do it, really. So that's your first one. Number two, it says being greater than this value is 0.4. So pretty similar to one we had on the previous slide, but with a different distribution. So you're going to do inverse normal of 0.6, which is going to give you 31.26, and then there's a couple of sixes. Let's do 31.27. Let's do the third one then. So third one, being between 10 and some value is 0.25. Okay, so let's sketch that one. it said 12's in the middle, so 10's over here. 0.25. Now, I don't really know where A is in relation to 12. It's not easy for me to place. I'm going to guess it's there somewhere. So the advice was start by finding the inverse normal of a value given in the question. So if you do that, you will find that this one, do I have this value? It's been done in a slightly unusual way on my notes, so I'm going to just quickly work that one out. So inverse normal, the area is, sorry, it's not inverse normal, is it? It's just regular normal. So that's my upper bound. My lower bound might be a number, say like, I'm just going to put minus 1,000, and let's see what that is. So if I do that, lower as minus 1,000, upper is 10, standard deviation was 3, mu is 12. I get 0.2524, I'm going to do 25, okay? So I get this value, and I want 0.25 on top. So what I need to do then is I need to add these values together. So if I add 0.5 onto it, I'm doing inverse normal of 0.5025. It's going to be very close to 12, this is. Yeah, it is. It's 12.018. So I'm going to put 12.02. Okay, so apologies there. What I meant to say before was I used the regular normal CD that we've already been working with within 3A and 3B to find out the probability attached to 10, and then I add it on. All right, so did we do one like that earlier? Yeah, so when we had this one, for example, the 16 would be an upper, and then my lower would have been a small number, and that would have taken me to that one there. So that should just say normal. Right, one more. Let's do one more together. So being, this one looks quite similar to the one above. Oh, but the 14's over here. Okay, so let's do, that's rubbish. Let's do another one. Let's do that. 12, 14. So being to the left of 14, I need it to be 0.32. So I need to, first of all, do my normal CD, yeah, with 14. And I should find that the probability of being less than 14 is, have I got that number somewhere? Yeah, 0.7475. So that's everything, right? But I only want to go down by 0.32. So I don't know exactly where that is. Let's guess that it's about there somewhere. So if I want that bit to be 0.32, then this has to be the difference of those values, yeah? So the difference of those values is 0.4275 approximately. And this is then the value that I'm going to do the inverse normal of. So I'm going to do the inverse normal of 0.4275, which will give me A is equal to 11.45. So I would encourage you to learn each of these situations because this more or less sort of covers it. If you draw a diagram, you're not having to force yourself to remember things, okay? It's a lot more intuitive that way. So we'll put some test your understanding questions up for you to pause and have a go at, but then hopefully you should be feeling quite confident about these. Okay, so answers, let's just give you some answers. So for A, it's 77.303. For B, 82.463. C is 70.34. And the last one, you've got to do quartiles again, haven't you? But then your final answer of the interquartile range should be 9.44. Okay, so I'm not going to go over each of these bit by bit because they were covered on the previous one. Here, you need to use 0.35. Here, you need to work with the 75 first and then add on. Okay, here, you need to work out what goes up to 76 and then take off from that. And for interquartile range is 0.75 and 0.25 that you need to be using. So that takes us up then to the end of the inverse normal section.